What if the same principle that gave rise to the genetic code could also redefine artificial intelligence? Welcome to the world of the Combinatorial Fusion Cascade, or CFC, a natural architecture that may lead us beyond backpropagation. The CFC was first proposed to explain how the genetic code emerged. Instead of chaos, life grew from competing protocodes that fused together in cascades, step by step merging and distributing information. Surprisingly, this very same principle can be mapped onto neural networks. In AI, the CFC behaves like a cascade of distributed modular subnetworks. Each module processes different types of information, like vision, sound, or text, in different ways, and then fuses them into a single global layer. This is distributed modality, a way for networks to preserve specialization while still achieving unity, much like the human brain integrates sight, hearing, and touch into one coherent experience. Today's large language models rely on fully connected layers and backpropagation. But these methods are computationally expensive, energy-hungry, and fundamentally unlike the brain. Geoffrey Hinton himself asked, "What's wrong with backpropagation?" The answer? It doesn't learn on the fly, and it requires endless cycles of error correction. CFC offers a path forward. Because of its cascade structure, networks can learn from a few convincing examples instead of millions of repetitions. In experiments, CFC-based transformers showed 10% higher accuracy on small datasets compared to standard models, with greater stability and lower variance. One of the CFC's secrets is complementarity. Just as DNA strands are linked by base pairing, CFC networks can preserve information across layers without retraining. This opens the door to non-backpropagation learning, where new modules can be fused into existing networks, instantly expanding their capabilities. Imagine AI systems that don't need giant data centers, but instead learn modularly, distributively, and adaptively, like the brain. With cascades, sparse connections, and complementarity, AI could become more efficient, more resilient, and closer to natural intelligence. The Combinatorial Fusion Cascade is more than a theory. It's a bridge, from biology to AI, from backpropagation to new brain-inspired learning. The future of AI may not be deeper, but instead more cascaded.